Assume you already installed the program. Installed program can be found under Menu Window, Floating Windows. Make sure it is checked. All functions can be accessed through the palette. The first button is to configure file directory, including basis atom file, unit cell file, and DHKL file. It is highly recommended to use the default setup. Next step is to set up unit cell through Cell button. Different approaches can be used for the setup. You can manually input all parameters, including lattice parameters A, B, C, alpha, beta, and gamma. Make sure the space group number is correct. Add the list of atoms, including element and atomic positions. You can use the symmetry operation to generate other atoms. Symmetry operation is very useful for complex cells which may include tens or even hundreds of atoms. You can also modify the atom list. When it is done, save the unit cell file. The second approach is through the Excel. Follow this format. Specify the lattice parameters A, B, C, alpha, beta, gamma, space group number, atomic number, and positions. Save the Excel file in the format of CSV. The program can read the CSV file for unit cell setup. Apply symmetry operation. A complete list of atoms in the unit cell can be generated. Another useful approach is through ICSD file. Here shows a typical ICSD file, which contains all the required information for unit cell setup: phase name, lattice parameters, space group, list of basis atoms. The program can directly read ICSD file and collect all information. Similarly, apply symmetry operation to generate a complete list. The unit cell file should be saved. The calculation of despacing and angle is based on unit cell setup. DHKL is to calculate despacing and generate a DHKL file. First of all, read the unit cell file. Next, generate a list of HKL planes. There are three different approaches. You can input a specific plane, a family of planes, or a list of planes. Once a list of HKL planes is generated, we can calculate the despacing and electron scattering intensity. Note that the extinction planes in the last list do not show up in the right list. The d-spacing and electron scattering intensity of a list of HKL can be saved to a file called dhkl file, which will be used for phase analysis. Next is to calculate a list of angles. Similarly, we need to read unit cell file first. Next, to generate a list of HKL planes, as we did for the HKL file. Click Calculate. We can get the angle between a pair of HKL planes in the list. As we talked before, d-spacing and angle calculation are based on unit cell file. The poly, SADP, and XRD are based on DHKL file. Poly is to simulate polycrystal diffraction pattern. First, read DHKL file containing d-spacing and scattering intensity. Specify the unit scale and image size. It is recommended to use the same setup as acquired images or patterns. Here shows the simulated diffraction pattern of polycrystal iron. You can adjust unit scale and image size and update the pattern. SADP is to simulate the diffraction pattern of a single crystal. Similarly, we need to read a DHKL file first. Specify the unit scale, image size, as well as the zone axis. Here shows the 111 diffraction pattern of alpha iron. You can adjust zone axis, unit scale, and image size conveniently. Here shows the pattern of 100 zone axis of alpha iron. CALU is a generic crystallography calculator. Read a unit cell first. Here shows how to calculate the d-spacing, angle between a pair of planes, and the zone axis. It can calculate extinction planes here. Next, to calculate the angle between two directions in the common plane containing these two directions. The tool can also calculate the goniometer difference between alpha 1, beta 1, and alpha 2, beta 2. The last one, XRD, is to simulate X-ray diffraction pattern. First of all, a DHKL file is specified. The beam is assumed to be copper K alpha. The lower and upper limit of 2 theta should be specified. Here shows the simulated XRD pattern. The HKL plane, d-spacing, and 2 theta are shown near each peak. You can adjust to set a range and update the diffraction pattern.